Section 3.4, the chain rule. Before we can even address the chain rule, we need to understand what a composite function is. And a composite function is a combination of two functions. It's a function of a function. So looking at this first example, if you look at the function m of x equals the quantity x squared plus 4 raised to the third power, it's a combination of two functions. One function is u to the third power. The second function is the x squared plus 4. And we write composite functions where we say a function of a function. So for this case, it would be f of g of x. Okay, so the definition of a composite function is that we have a function of a function. So looking at our first example, that f of u equal e to the u power and g of x equals negative 3x. Find f of g of x. So what's inside, let me highlight that instead. What's inside is placed in place of the variable in the outside function. So f of g of x would equal e to the negative 3x. And if we do the reverse, g of f of x means that now I put the f of x in place of the x in the g of x function. So this would be negative 3, and I replace the x with e to the u. And certainly you could change that to x's. Okay, so you try match problem number 1. Now let's write a composite function as two separate functions. So in the first example here, what do we have? We have our, let's just say f of u is our e to the u, and our g of x would be our 4x. Okay, looking at the next one. Think of this as 4 minus x squared to the 1/2. So our one function would be u to the 1/2, and our other function would be what's inside there. Okay, so you have 2 to try. Okay, so let's look at the general power rule. The general power rule states that we take our exponent, bring it down front, times our function raised to the n minus 1. But since it's a composite function, it's a function within a function, we now need to take the derivative of what's inside. So looking at our first example, we need to do our regular power rule, which states bring the 4 down front to the n minus 1. But now we need to take the derivative of what's inside. And then you might want to just clean that up, simplify it. Okay, find the derivative of y equals x to the third plus 4 raised to the 7th power. Bring the 7 in front to the n minus 1. Take the derivative of what's inside. And since that's a monomial, we can clean this up a little bit. Okay, let's look at this example. Rewrite this. Using negative exponents. Anything in the bottom can be brought back up to the top by negating it. So the derivative, using our general power rule, bring the negative 3 in front. Subtract 1. Negative 3 minus 1 is negative 4. And then take the derivative of what's inside. You can rewrite that if you like. This would all be in the top or the numerator. And then our denominator be raised to the 4th power. You have some to try, keeping in mind that you want to rewrite d. I didn't have an example for d. Rewrite that to the 1/2 power. Rewrite c to the negative power. Okay, I'm going to end a part 1 here, and the second video